Hello everyone. So welcome you all in our first video of third module. So in this video we'll start with the motivation, why we required convolution neural network, why ANN is not efficient way to deal with the image or video data. So let's go into the detail. So here we'll talk about the motivation behind the convolution neural network. Before jumping into that, let's first look into the convolution neural network around us, where we are utilizing this CNN to solve some problems. So I hope we have a smartphone which have feature of face unlock. That face unlock itself used convolution neural network. Similarly, there are many painters that is trying to make new images by clubbing two or more images. That is known as style transfer. Similarly, with I think most of the smartphone camera now coming with the image quality enhancement or beautification. And in order to find the places where you have to beautify the image, that required a convolution neural network behind it, right? Now if you look into the object detection problem, especially in self-driving car, then it's utilized the convolution neural network. Similarly, gesture recognition. So there are plenty of applications which are utilizing the convolution neural network, and they are around us. So let's understand why convolution neural network is so powerful and what is the problem with the basic artificial neural network. So let's start with a simple problem. Suppose I want to recognize this handwritten character A. Now this character or this image has 16 cross 16 input image. Right? Now in order to feed this image, we require 16 cross 16 nodes so that each pixel is going to one node. If it is a black and white image, but if it is a colored image, then we require 3 times of these nodes, because then the input size is 16 cross 16 cross 3, as we have seen in the previous module. So we required, so in this example we are taking black and white image, or you can say grayscale image. So we require 256 nodes to take the input of this particular image. Now we have, suppose we have one hidden layer that will be connected by all the input nodes, right? And then finally we have an output layer which have total number of outputs to say with respect to A to Z, so that we'll able to classify a particular character in the image. Now if you are dealing with the simple ANN model, how many parameters we required? So suppose we have 16 cross 16 image, and in the hidden layer we have just 100 nodes, right? So in that case, how many weights you required here? 256 into 100 plus 26 bias. Now if you look into this side, how many weights we required? 100 into 26 plus 26 bias. So total, so here we require 100 bias and here we require 26 bias. How bias is calculating? So you will have a bias that is 1 and it is connected with all 100 units. So required 100 bias, and here you have one bias unit that is connected with all A to Z, that is 26 bias. So total number of parameters to solve this simple problem with only one hidden layer require 28,326 parameter, which is extremely large number of parameters to train this model. That is become very complex problem to training this kind of problem or this kind of model to solve this very simple problem. Now here we are talking about the beautification, we are talking about the face recognition, which is very complex and required very deep neural network, where we have multiple hidden layers. So in that way we have n number of layers which have many weights. Now what problem in this that we need to understand, so that we will evolve a new variety of network. So first problem, ANN has too many parameters which is not required many times, right? Why we have too many parameters? Because it is a fully connected model. Now the question is, do really need all the edges to solve or to classify a particular example, right? Can we share something from the other data as well, or you can say other nodes as well? So now let's look into this. So before jumping into that, let's try to play game. Now just identify, is there any image? So suppose I want to identify there is a bird in that image. So how many pixels you can throw, still you are able to identify there is a bird. So now someone say I can throw 10% pixels, someone can say 25% pixels. Might be someone thought of, okay, let's throw the background, keep the bird image. But if you already know where is the bird, then what is the need of identifying it? Means you don't know that bird is in the picture. That model should take it out that okay, bird is available in the picture. So once you throw the data, means it's a systematic throw. Suppose I want saying I want to throw 50% of the data, then what you will do, you will keep one pixel. Let's say you are keeping this, removing second one, then you are keeping this, removing third one, and so on. Keep this, removing this one, and so on. Irrespective it is belong to the which portion of the image, you will continue this process. So at the end you will have only 50% of the pixels. So then you are saying we are removing 50% of the data. So let's think how much information we can throw it. So someone say 10%, someone say 20%, someone say 30%, but actually we can throw even more. So suppose you have throwing 75% of the data from this image, then it will look like this. Now you can say what is the difference between them? They look same. So yes, this particular technique is known as subsampling. So this is the original image which is much bigger, and this is the subsampled image which have only 25% of the pixel. Means if you are trying to solve a classification problem, then even if you are keeping only 25% of the information, then also you are able to classify a particular object or particular image in a proper way. And this entire concept is known as subsampling. Now once you take only part of the data, means you require lesser computation, because if suppose you have a size of, let's say, 16 cross 16 image here, now you are keeping only 25% of the data, you are throwing 75% of the data, then you will have only 4 cross 4 image here. That is really, we are reducing the total number of parameters by 75%, right? So that will make your image smaller. So we will have fewer parameters to characterize the image. So now what the major difference? So ANN suffers from curse of dimensionality. It has huge dimensions as we see in the image or in the previous picture. Then in case of CNN, we are using spatial locality. Now what is the mean of that spatial locality here? So the exact meaning, suppose we want to watch a big image with the human eye, or I want to watch a big image, but we are very close to that image, so we cannot see the entire image in one go. Then what we will do, we will start from one end and slowly we will move and we will reach to the another end. So you can say, suppose we have very big image in hand, then you will start from this end and slowly you will watch this entire image and you will reach here, and finally once you reach, go through the entire image, you will conclude it. The same concept, so this particular concept in the images is known as spatial locality. Means while you are processing this data, you are only talking about the spatial information. Then you are talking about, if you are dealing with this, then you are talking about this spatial information. Once you move here, you are talking about this spatial information. So in that way, we are utilizing the spatial information and trying to find out the patterns, right? So what CNN is doing, CNN is first thing it is sharing the parameters, and they have sparsity of the connection. Their connections are really sparse in the nature. So that's the reason why we required a different variety of network, that is convolution neural network, to solve or to deal with the image data, because the data is very big in the image. If you have a tabular data, then ANN can works well, but if you have image data, and you can see nowadays we have the images very high definition image, so you can say your size of the image is really large, and if you have large image means more number of pixels. If you have more number of pixels means you require more neurons to deal with this image, so that will create a big problem for ANN. So in the next video we will see the building blocks of CNN, the very first building block of the CNN, that is convolution neural network. Then you will understand very well how we are sharing the parameters and how it is sparse in the connection. Okay, so then let's go to the next video.